recording now. Okay, so I do need a separator here for the reason that some of the reactant I don't want to waste. Sorry, I don't want to waste them. Okay, so I'm separating them, as you can see here. طبعا, this problem I can solve it. Okay, if you calculate the degree of freedom for this 2-unit system, you will find that the degree of freedom is equal to 0, and I can solve the process. Basically, I can solve the process. When you solve the process, we are going to get these results, as you can see here. So these are the flow rates of the 2, 3, and 4, as well as the associated composition. The associated composition. So this is something that you can try it yourself. However, Shabab, when we look at the solution, when we have a close look at the solution, we choose stream number 3. So this is stream number 3. And this in stream number 3, we can see the amount of the carbon monoxide and the hydrogen. We can see they are huge, صح? They are big amount from the stream 3 are carbon monoxide and hydrogen. And if I just keep this one go like this, basically I am wasting them. So in order to decrease these losses, we have learned a strategy in 111. We call it a recycle, where we have to recycle this stream back to the system. وبالتالي I don't lose. Therefore, I don't lose my valuable reactant. I don't know if you know, for example, in GPIC, we are getting the CO and the hydrogen from a process, سميها steam reforming. And it's a highly endothermic process. Lots of energy has been put there. In addition, we have a catalyst, an expensive catalyst is used in order to produce the carbon monoxide and hydrogen. So it makes no sense after doing all and putting all this effort in producing carbon monoxide and hydrogen to lose them. بالتالي, I have to recycle them. When I recycle this stream, an additional unit show up. Anyone can tell me what we call this now? What we call this circle?
Mixing point.
A mixer. We have a mixer. So here we have only 2 unit operation. We have a reactors and the separator. Now we have a 3. We have a 3. We have the mixer, we have the reactor, and we have the flash separators. طيب شباب, now if I continue recycling this stream, we have a problem. Anyone can guess what is that problem?
Overflow.
Overflow? No. Look at the reactants.
The composition will change.
The composition does not change. Any other suggestion? What happened to the methane? What is going to happen to the methane? I'm recycling and I'm putting methane every time. Methane قاعدين من هني وقاعد أرد. What will happen to the methane?
Side reaction.
Side reaction? No.
It will enter the reactor.
It will enter the reactors. أكيد كطالع من الreactor. But there is a specific problem. Yes, thank you, Khalil. مثل ما خليل قال شباب. What happened to the methane? The methane will start to accumulate. لأن قاعد كل شوية I have a fresh methane. وما قاعد يستهلك. It has not been consumed. And I'm just recycle them. It's like we have a buildup of methane here. صح? I have a buildup of methane here. So that's a problem. How to solve this problem?
We can use purge.
Exactly, Ali. Noor, yes. Okay, so we have an inert circulation here, and a solution of this is that we need to purge to reduce the accumulation of the inert. As you learn from your, again, 111 course. Now, can you see that another additional unit operation show up here? What we call splitter. We have a splitter. So let's now compare. Here, without a recycle, we have 2 unit operation. Now with the recycle and purge, we have 4 unit operation. 4 units, okay? 4 units. Mixer, reactor, separator, and splitter. And how many stream we have now? مساء كان عندنا only 4. Now, how many stream you have now? 7. We have 7 stream in this problem. So you can see that the recycle stream, it provide for us it did for us good favor, that it would reduce for us the loss of our reactant, valuable reactant. لكن المسألة تعقدت في الcalculation شوية. Okay, I have more stream now, and we need to solve this system. Now, for us to solve the system, as usual, we have to start with the degree of freedom, which is non-trivial thing. It's a very important thing, especially when you're going to use the flow sheet simulator. Okay, so degree of freedom is extremely important concept, and any student in chemical engineering has a problem with understanding the degrees of freedom. He has a serious problem, or she has a serious problem. This is something that you really have to fix. Right, let's look at this system now. Look, I'm going to calculate the degree of freedom for every unit, and because I want to decide which one I should start with. So when we look at the mixer here, we have 11 variables. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11. The number of equation, we have 4 different species. So we can write 4 independent equations, or 4 independent balance equations. Now we can see here we have 3 given variables. So the 3 given variable, actually this is 3, assuming that I don't have the bases, or you can think about them as the 2 of these as well as the bases. So we have a 3 given information, 3 given piece of information. Okay, 3 given independent piece of information. Either 2 of them and the bases, or the 3 of them. Okay. Any available relation between the stream اللي داخلين في أي علاقة between the stream اللي داخلين على المixer? Nothing given here. So we have 0, so we have 4 degree of freedom. Okay. تمام. Now let's move to the reactor. In the reactor we have 4 species, then we have 8, and we have 1 reaction going on here, which is this reaction. So we have zeta. So we have 8 plus 1. 4 species, 4, no any given variable. The number of available relation is just the conversion. Okay, so CO conversion is 60%. So this is a relation that's related for you stream 2 to 3. Okay, so again the degree for freedom is 4. تعال حق الفلاش. I have 4 here, and stream number 5 has 4 variables. So we have 12. The number of independent balance equation is 4, because we have 4 different species. None given variable. Any available relation given to us that relate the stream that belongs to the separator? Yes. We have this relate stream number 3 with 4, and this which is relate 3 and 4, and this that relate 3 and 4, and this relate 3 and 4. So we have 4 relation for the flash. So the degree of freedom is 4. تعالوا حق السplitter. Now for the splitter, Shabab, as you can see again, we have 12. So we have 1 stream here, and then there is 2 branch حق السplitter. فكل stream هني أو كل branch في 4 components, so we have 12. Again, we have 4 species, then we have 4. No any given variable, it's a 0. And what about the available relationship? We have seen here that we do have 1 relation that tell us that stream number 6 is 10% of this stream. And also probably, as you remember from 111, that there is an extra relation. We do have it when we deal with a splitter. Anyone can remind me what is that relation? Same composition. Thank you, Ali Abdul. Exactly. Okay, Shabab, the composition of these species are exactly the same here as well as here. And how we take this into consideration by having what's called the splitter restriction or the splitter relation, if you like. Okay, and basically the splitter restriction or the splitter relationships will facilitate the calculation. So I should count them, should consider them among the given relation in our problem. شلون نحسبها شباب؟ نحسبها عن طريق مثل المعادلة اللي شايفينها. Okay, so we have M, which is the number of split. So here we have two split. اللي هما the stream that leave the splitter. Those are the number of splits. Okay, so if I have something like this, where did it go? Okay, so I have one coming here, and then I have 4 goes out. So number of the split is 4. And then N is the number of components. So in this particular problem, we have 2 splits, which is M minus 1, and then we have N, which is 4, because we have 4 different species, minus 1. So we have 2 minus 1 is 1, multiplied by 4 minus 1 is the 3. So we have the three relations. Come on, this is 3, is the 3 relation that has been imposed by the splitter. And then we have this one, which is that ratio given to us. Okay, so based on this, the degree of freedom for the splitter is 4. So I cannot solve the splitter. طيب تعال حق overall. Now, when we look at the overall, it means that we are putting like a rectangle, big rectangle here. And then we have the stream that are involved is 1, 6, and 4. So how many stream we have? Sorry, how many variable we have? We have 4, 4, 3, so 11. And of course, there is a reaction going on inside this box. So we have to consider one extent of reaction for that reaction, which is basically this reaction. So we have 11 plus 1. On the overall picture, we have 4 species. We have still 3 given variable, which are these. Any available relation? Any available relation for the overall? We have 6 here. Any of them belong to the overall? None of them. None of them. 0. Why?
الكونفرشن ما نحسبها وياهم.
No. Can you tell me why no? Or anyone else can tell Ali why no? Why we don't count the conversion, Shabab? Because the conversion basically relate which stream? Which stream are related? Ali? 2 and 3. And is 2 and 3 part of the overall picture?
No.
No. Then we don't consider the conversion. What about the other? Let's look at this 4 and 3. Well, someone would tell me, oh, look here, we have 4. And then I'll tell him yes. But this relation relates us 4 with a 3. And a 3 is not part of the overall picture. I mean by overall picture, stream 1, 6, and 4. So if I have a relation that relates 4 and 6, or 4 and 1, or 6 and 1, then this is the relation that you should consider. لكن هون كل العلاقات هني relate, يعني look at the last one, it relates 6 and 5. Unfortunately, 5 is an internal stream. It is internal stream, so I don't count this relation. So we have 0. So you can see that I cannot solve the overall. I have 5. The degree of freedom is 5. What about the process? In the process, we consider everything. So we have 1, 2, 3, 4, 5, 6, 64, 24. And then I have 3 here, which is 27. And I have 1 reaction goes here, so I have 27 plus 1. The number of independent equation I can write 4 for the mixer, 4 for the reactor, 4 for the flash, 4 for the splitter. So I have 16 equation. The number of given variable are these 3. The number of relation, now I'm talking about the process. So I'm going to count all the relations. So 1 plus 4, 5, 5 plus 4, 9. So you can see the process is solvable. يعني أنا أقدر أحل البروسيس. أنا أقدر أحل البروسيس. Now, شباب حط بالك. If I give you this a problem when I was talking about AX equal P problem, لما أنا كنت أتكلم عن AX equal B, so you would tell me, yeah, the degree of freedom of the process is 0, system ينحل دكتور, and then I can use AX equal B, and I solve this system simultaneously. يعني أحلهم كلهم سوا AX equal B, then my unknown, okay, my unknown will be the inverse of X مثل ما سوينا في الquiz والtest. Right? And then you get the answer. However, if I'm going to solve the problem in HYSYS, remember how HYSYS works? You remember how HYSYS works? I start first of all defining my material stream, which was blue, I think, yeah, it was blue. I'll go معرف الstream. Then I put a mixer. And then for that mixer, I'm going to define stream number 7 and stream number 2. But what is the problem here? Before I move to the reactor, before I move to the conversion reactor, I have to make sure that this guy is solved. But if I'm going to do this with a system, with a recycle, what do you think? Am I going to be able to solve this guy? Yes, no?
No.
No. No. Why, Amina? Why I cannot solve? Why do you think?
In order to get the compositions of stream 7, we need to, have the conversion through the reactor, because then the separator will come and then the splitter and all that.
Exactly. So in other words, what Amina is trying to say, I won't be able to have this 4. I won't be able to have this 4 unless the reactor is solved and the separator is solved and the splitter is solved. And then only I will be having this 4 things here. Then I'll be able to solve the mixer. This is one way to look at the problem. Another answer could be, دكتور أنت تشوف mixer degree freedom 4. You can see that for degree freedom mixer is 4. You cannot solve it. It won't be solved. Its degree of freedom is 4. For you to be able to solve it, this must have a degree of freedom 0. Agree, Shabab? So how can we solve a problem with a recycle in HYSYS? That's why we need a special strategy. Now this strategy, Shabab, اللي يستخدمها HYSYS, I'm explaining to you the strategy. Then you will see how we're going to do this in HYSYS. It's just a block. But I'm going to explain to you how that block works. Now here, as you can see, the strategy is calling the tiering techniques. What does it mean, tiering? شنو يعني tiering? What does it mean, tiering?
Cut, yeah.
Cut, Shabab, exactly. Manata, I need a Caesar. I need a Caesar. I don't know if that looks like a Caesar. Okay. Okay, I'm very bad in drawing, but hopefully you can see it's a Caesar. And why we need the Caesar? Because we need to cut something, right? And what we are going to cut? We are going to cut one of the stream inside the recycle loop. We are going to cut one of the stream in the recycle loop. And what is the recycle loop? That's the recycle loop. So I could cut the stream 7, I could cut the stream 2, I could cut the stream 3, or I could cut stream 5. كيفك, up to you. Let's assume that we are going to cut the stream number 7. One might ask me why you want to cut that stream. Because I'm going now to introduce for you an iterative strategy or technique that is called the tiering technique. يسمونها tiering technique. And why we need to cut? I'm going to tell you why we need to cut. Look here, Shabab. What we are going to do is the following. We are going to cut this stream, 7. And of course, you can see that the same material here is the same as here. They were the same pipe. They were the same line. I'm just cutting them. So what I'm going to do, Shabab, I'm going to assume values for these 4 species. And that's why I'm calling it 7 assume. This stream, I call it 7 assume. Why? Because I'm going to assume the 4 flow for this 4 component. Now let me ask you the same question. After I'm assuming this 4, do you think that the mixer will be solved?
Yes.
Ali Abdurrahman يقول no. Anyone else? No. Amina say no as well. Still need one. Iteration. Okay. Now I'm saying, okay, let me ask the question بطريقة ثانية. If I'm assuming this 4, does the degree of freedom of the mixer will become 0?
Yeah.
Yes, the degree of freedom becomes 0, but probably you are اللي قالوا no أعتقد قصدهم that won't be the correct answer. I think that's what they are trying to say. Okay. لكن if I am just putting any 4 piece of information here, you can see that the mixer will be solved. This is an initial guess. فأحط 4 قيم عندي هنا, and when I put 4 numbers here, what will happen to the mixer? It's mean now I am having 4 given variables 7 صاروا. So this will be 0. That will be 0. It's mean now I can solve the mixer. I can solve the mixer. When I solve the mixer, follow me Shabab. When I solve the mixer, I will be able to know stream number 2. صح ولا غلط? Right. So I will be able to know the component or the species in stream number 2. What happened to the reactor degree of freedom? It will be equal to the reactor degree of freedom will be equal to 0. It will be equal to 0. Yes. معناته I can solve the reactor. Now I'm going to solve the reactor. What will be known? Stream number 3. What will be the degree of freedom for the flash separator? 0. Because now I know this 4 piece of information will be added to the flash as a given variable. That will be 0. معناته the flash separator solved. When I solve the separator, stream 5 become known. Stream 5 become known. What will be the degree of freedom for the splitter? What will be the degree of freedom for the splitter? 0. It will become equal to 0. So I will be able to solve the splitter. When I solve the splitter, now I'm going to have this 4 component, and the 4 component in the 7 calc. So this is the 7 calculated. على اليسار, on the one on the left, we call it 7 assumed. The one on the right, we're going to call it calculated. This is assumed, and this is calculated. So basically, I am calculating stream number 7 from the right. طيب, what's next? Next is you have, anyone can guess what is next? Anyone can guess what is next? Iterate.
Yeah. Set 7, calculate to 7.
Well, does that remind you about something? Does that remind you about something? Remember that stuff? You remember that stuff?
Loop.
So basically, this is like what? This is like the X in U, right? And what I'm going to do, I'm going to tell him X old equal X in U. So basically, I'm going to tell him here, that the 7 assumed now will be equal to what? To 7 calculated. Before I do this, I have to check the error. I want to see the difference, the absolute, if you like, between 7 calculated minus 7 assumed. What are they supposed to be? What are they supposed to be, 7 calculated to 7 assumed? It's supposed to be the same, صح؟ أنا المفروض هاي نفس stream واحد. It's just one stream, I cut it. I cut it. صح؟ And if I cut the stream number 4 here, you can see the thing comes from the bottom. It's the same as composition as the one here. So I'm cutting. So if my assumed value from the beginning was correct, let's assume that I am super lucky and I start with an initial value here, and then I do the calculation. As you can see that 7 calculated will be equal to 7 assumed. Then stop, I have to do nothing. However, most of the time you won't be super lucky. I'm going to select just a root initial guess, and then you will start with that values, and you will calculate 7 calc. بتلقى هذه مو مثل هاي, في difference, في error. Then you are going to take this and you calculate it and put it here. Happy, stop. Not happy, continue. Happy, no. Then take 7 calculated, put it 7 assume, and do it again. Happy, yes, then converge. So you can see, guys, that in the background we have kind of, what is the name of the problem? What is the name of the problem that I've been mentioning it maybe 1,000 times in the course now? Trial and error. The problem itself. نسميها root finding problem. Okay, so we have a fruit finding problems in the background, and we need to use واحدة من the root finding methods اللي هي من هي الجماعة اللي نيوتن رافسون دوسيكنت. But you will see one of our friends that we learn about it in this course is the one that we are using. Hadiguli, what is that technique that you have learned it in a 315 and you haven't learned it somewhere else? What we call it? Okay, let's write it in a blue color. Anyone know it? Anyone know it? The
Weinstein.
The Weckstein. على وزن Einstein. The Weckstein method, شباب, هي الطريقة. It is the method that's used to do this iteration. Or you can think about it as a secant. يعني كأن secant قاعدين يستخدمونها يسوون لك iteration. So that's basically the tiering techniques. Very simple and easy. Okay, very simple and easy. So the steps involved here is the following. You assume a stream, you calculate stream number 2, and then mixer بينحل. Okay, because once you assume here, مثل ما قلنا degree of freedom 0, you solve this. Then you calculate stream number 2, then you solve the reactors. Okay, because the degree of freedom now is equal 0, so you can be able to solve the reactor. You will know this. هذه 0, هذه 0. and then you compare the 7 assumed with the 7 calculated. Happy, stop. Happy, take this and put it here and continue. So it's an iterative procedure, Now you can see in this problem in particular, okay, it would be better, in fact, in this problem, it will be better to tier stream number 2, not stream number 7. I will tell you why. الchoice هنا طبعا بيسهل عليك عملية الcalculation. If I ask you to tier number 7, you have no idea what could be a good initial guess to start with. But for stream number 2, as you can see, it might be easier for you to guess. ليش it's easier? Because I'm doing a mixing here. So you can see that I am entered here as a 33% of the 1,000, which is a 330, okay? And I'm adding more CO. So I can guess that the CO that goes out has a concentration higher than this because I'm adding more CO here. So that's why if I'm starting with a 330, I'm gonna start with a good initial guess of 400 here. Okay, نفس الشيء الهيدروجين هي on a body of 62. Okay, 620. I could start with 700 or 800. Okay, and the methanol is actually 0. صح؟ لأن I don't have أصلاً ethanol here yet. Okay, so I could start here with a 0 or just a small amount because it's just been produced. So why stream 2 is a better candidate to be tiered or cut? Because I would have a good initial, I have a way to suggest an initial guess. Okay. لكن in fact in HYSYS it doesn't matter. يعني اللي بتحلها في الماتلاب, sorry في الإكسل. يعني here the solution was done in Excel, and as you can see what he did, he assumed values for stream number 2, okay, and then the mixer will be well, if he assumed for stream number 2, you can see that the reactor degree of freedom will be equal to 0. Then he will be able to solve the reactors, which is stream number 3. And once he solved the 3, بيحل الفلاش, بيحل المixer. And once he solved the mixer, the splitter, he will know this, and then the mixer will be solved. And then he will be having 2 calculated, okay, which is here. So 2 assumed is here, and 2 calculated is on the left, okay, which is to the right, to the right of the mixer. طيب شو نسوي في الإكسل just to give you a feeling? What we will do is we are going to define هنا column اسمه difference, where we take the difference between the assumed and the calculated. So this is the difference between the 2 assumed and the 2 calculated. And then we are going to square. So each value of this, we are going to square it just to get rid of the negative value. And then we are going to sum this column. So this is like a number that represents the error between the assumed and the difference. So we compact that difference in just one number. فهي كعبارة عن رقم يمثل لي الفرق بين ال 2 assumed and 2 difference. And then in Excel, you can do it easily باستخدام الsolver. I'm going to just show you the solver utility in Excel. Okay, if someone used it before, معناته يعرف. اللي ما يعرف, it's just an optimizer, okay, which will trying to make that sum of the square, يعني بيحاول يخلي sum of square equal to 0. Okay, I'll show you. Okay, so if we start Excel here, okay, فعندنا شباب بتروح على الداتا, عندنا where is the data? You go to the data, we have a solver. Well, where it is, not a solver. If you cannot find the solver, then you can install it by going to go to where? go to options, and then goes to the add-ins. Here عبارة عن add-in في Excel, and then you will find it here, solver. And then you go go, and then you take the solver, تقول له okay. And لما تروح على الداتا بتحصله. Okay, you will find it under the data. It's here. So what the solvers do for you, the solver, وين النوت مالنا? Yeah. Okay, so in the solver, we can use the solver. بنقول حق الsolver, set this objective, which is basically this cell. هذه cell, okay, حط الvalue مالتها 0, because I'm trying to minimize this error. And we want you to, we are asking Excel, we want you, Excel, to make this numbers 0 by adjusting the 4 assumed value. So here, by telling him, by changing the variable in this 4 cells, okay, try to make for us this guy equal to 0. So after selecting this cell, I'm putting it here. And after putting value of 0, and then by here, by changing this variable cell, I select this 4. بعدين أقول له solve. You will see that Excel will trying to solve for you this problem. Okay, فتشوف هنا طالع لك 2.7 exponential minus 7, which is almost 0. And you will see that this value now is equal to this value. Then the difference is almost 0. And that means that your solution converts. So this is how the tiering method works. This is the idea, the concept behind the tiering method. Now we are going to see how HYSYS solve for us this. For HYSYS, we don't have to do all these details, but you will find it very useful in a minute. Okay, in a minute you will see how useful is what we have explained in understanding how the HYSYS recycle block work. طيب خلينا نحل المثال هاي شباب. طيب, in this problem شباب عندنا ammonia. We are producing ammonia. طبعا الامونيا من البتاع من بعض من البرودكتس that GPIC is the Gulf Petrochemical Industrial Company اللي عندنا في البحرين تنتجها. Okay, so they are basically having nitrogen. ياخذون من وين يطلعون النيتروجين? Any guess where do they get the nitrogen from?
Air.
من الاير. And where do they get the hydrogen from? Well, we are trying to produce ammonia, Amina. We are trying to produce ammonia. So we need nitrogen and hydrogen. So where we get the nitrogen from? Ali Shukrallah Galina from the air. That's correct. And where we get the hydrogen from? Any idea? Any idea?
The reaction that you showed us first.
Exactly, Shukrallah. Mumtaz. Exactly, Shukrallah. From the reaction that well, actually, what I showed you earlier was producing the methanol, okay, producing the methanol, but the thing is, طبعا هي عندك اثنين, so we need to balance. No, that's 4. Then you have 2 here, yeah, because we have 4 hydrogen, 1 C, yeah, 2. This hydrogen and carbon monoxide, مثل توني قايل لكم من شوي, this is a process, a reaction, we call it steam reforming. Steam reforming will produce for us this too. Okay, so this is a very important process which you guys see. Someone has steam reforming. It's a highly endothermic reaction. ينتجون من الهيدروجين والكربون monoxide. So you will get the hydrogen from steam reforming. You get nitrogen from the air. خليهم مع بعض يعطونك ammonia. Anyway, so let's assume we have a reactive process where nitrogen reacts with hydrogen to form ammonia, and the reactor yields a single pass conversion. شنو يعني single pass conversion?
يعني overall conversion.
Are you agree with Fikrallah ya Rabbi? Single pass conversion is an overall conversion. You agree with him?
لا أقصد حاجة reactor دوك الأول.
Do you agree, guys? What is single pass conversion?
بس الreactor.
بس single pass معناتها مرة واحدة يمر على الرياكتور، صح؟ مرة واحدة يمر على الرياكتورز ويسوي لك conversion. اوكي. طبعا conversion شباب هاي بالغلط مكتوب 60%. This is 35. Please write down this notes. هذه 35%, not 60%. Okay, let's start do this in HYSYS. Okay, so we will start, of course, as usual. Tell HYSYS what is the component اللي موجودين عندنا في السيستم. So I'm going to add a new case. Okay, وأقول له add. بعدين I will add, sorry, procedure reaction. Okay, add component. So what do we have? We have nitrogen. We have hydrogen. We have ammonia, NH3. Okay, so these are the 4 species we have here, Shabab. And Shabab, I want also to get the normal boiling point for a reason. Okay, نبي boiling point for a reason bad. من وين طلع boiling point مالهم? The normal boiling point. Where do we get it from? Say double flex, yeah. So when I go here to the critical, I will find high nitrogen. So the nitrogen, وين القلم؟ Okay. النيتروجين كم البتاع ماله؟ normal boiling point ماله minus 195.8. شكرا نيتروجين. هيدروجين كم البتاع ماله؟ minus هو أصغر صح؟ هيدروجين minus 252.6. وباقي الأمونيا كم الأمونيا؟ minus, so the ammonia NH3 is minus 33.45. Type Shabab, based on what you see here, based on this number, which is the heavier component? What is the heaviest component? Ammonia. ليش؟ لأن عندها أكبر درجة غليان، صح علي؟ Has the largest. Largest because it's a negative. Okay? Because it's a negative, so it's the largest. The smallest number become the largest because of the negative sign. So also, which component of this has the highest vapor pressure? Which one of these components has the highest vapor pressure? Hydrogen ولا nitrogen ولا ammonia? Which one has the highest vapor pressure? الأخف. Okay, الأخف دائما عنده the highest vapor pressure. So the highest vapor pressure is for hydrogen. دائما الأخف هو اللي عنده the highest vapor pressure. Okay, فهو اللي يغلي أسرع. هو اللي يغلي يعني لما يكون عنده high vapor pressure معناتها it can overcome the atmospheric pressure يعني يقدر عليه يقلبه ويتبخر. Okay, لأنه هو الأخف صح؟ فمعناته عنده the highest vapor pressure. So it has the lowest boiling point and the highest vapor pressure. Are you agree with me شباب ولا مو بعجبكم اللي أقوله؟ إذا حب عجبه يقول لي. ترى أنا ديمقراطي. Agree? طيب. Then we have defined our 3 material. Then let's move. We go to the fluid package. I'm adding he told us actually to add for this system, SRK is good. So he told us to add the SRK as our fluid package. Then we go to the reaction. We can add our reaction. It's a conversion reaction because we've been given the conversion. It was single pass conversion. So we have, let's see. Nitrogen, and the nitrogen, and the hydrogen, and the ammonia. And the nitrogen is -1, -3 when we have 2 ammonia. The conversion of the who? 35 single pass yield the single pass conversion told us here with 35% conversion of nitrogen and 35 حق النيتروجين. So the last thing is we have to add the fluid package to that, and then we are ready to move to the simulation environment. Okay, now in the simulation environment, we have two stream here. So we are going to add this two stream here. This stream is he told us here that stream 1, which is nitrogen, let's call it nitrogen. This stream has a temperature of 450 degrees Celsius, 450 degrees Celsius, and 200 200 atmosphere. It's very high pressure. 200 atmosphere. Okay. And the flow قال لنا 100 kilomole, so that's 100 kilogram mole per hour. And of course, the composition here, that is a pure nitrogen. So بيصير عندي 1 normalized 0, so the stream converge. And then I have hydrogen as well. فبيكون عندي H2, بيكون عندي temperature 450, بيكون عندي ال pressure 200 atmosphere as well. Now I'm going to keep the flow براويكم الست شلون بخليه automatically connected to لأنه already عندك 3 to 1, okay, because of the stoichiometric coefficient. فإذا عندك 1 هنا عندك 300 هني. I'm going to do this through the set so I can introduce you to the set utility اللي موجودة في HYSYS. Okay, so unknown flow rates. So because we don't know the flow rates, but we know from the stoichiometry that it's 3 times this, we can use the set. Maybe I have introduced it before, but if I don't, then the set شباب عبارة عن linear relationship. So y is the output, which is the flow rate of the H2. Okay, so that's the target variable. So for H2, I want to set the molar flow. So I'm going to the molar flow, which is this one. So let's select. And the source that I'm going to اللي هو ال N2. فطبعا هو على طول أنا بنكتب mole flow rate هو يعرف إنه you're going to go to this guy and use the same variable. And why? How I know this? Because he has to add them. He has to add them. فشلون add them? You can see it's a straight line equation here. So y is the H2 molar flow, which is this stream, and x is the input stream, اللي هو ال N2. And you can see that I can introduce the multiplier. I know that the hydrogen is 3 times the nitrogen. فتشوف هنا حتى الثلاثة تغيرت. And you can see now the stream is converged. So when you collect here inside, بتشوف ان المولر flow 300. And it's a black, معناته it's being calculated. So you can use the set أو انك تدخلها عادي, بس يمكن فرصة اني I reintroduce for you the set. The set only work for a linear relationship. For non-linear relationship, I cannot use the set. شنو استخدم لو كان عندي non-linear relation? What can I use?
Adjust.
Adjust? لا, if I want to calculate a value, if I calculated y, but this only work for linear. If I have non-linear, I use?
F-solve.
No, أي F-solve, احنا في الهايسس. راح أخذ لك قهوة تعال. صب لك فنيال.
Worksheet.
The spreadsheet, مو بالworksheet. The spreadsheet. شوف تروح عليه شوف تكتب لك spreadsheet. Okay, so that is our feed. Next أخذهم على mixer أو ندخلهم على reactor, but we need the mixer here. You will see later why we need the mixer. فبقول لك شوف الميكسر الحين degree of freedom مالته تنحل. كيف بقول له نيتروجين هيدروجين وبقول له ستريم اللي طالع كم مسمينه 3. Let's call it 3. على طول الميكسر انحل. Very nice. So then what? Then I'm going to take the reactor. So يبقى على الرياكتور وينه الرياكتور؟ هني conversion reactor. Okay. right? Yeah. And then I'm going to, has he told us anything about, yeah, ما قال لنا شيء عن temperature, so it's adiabatic. So I'm going to, أقول له 3 اللي طالع من الميكسر, and شنو سموهم ذلين؟ 4 و L. He called them 4, and he called this guy L. And since he doesn't tell anything about the temperature, so it's adiabatic. فقال لي أبي reaction set. I want you to attach for me the reaction that happened here. فبقول له take set 1. شوف حل. So now the problem is solved. Problem is solved. Okay? And everything nice here. So we have just to check what is the molar flow rates اللي عندنا حق the stream اللي عندنا. فقال لنا عندك 65. So let's bring it. فشلون اجيبهم؟ الاسرع اني انا عشان رويتكم مرة راحت اروح على الكاستمايز data table واقول له add for us the flow rates the stream 4. Yeah, stream 4. راون الفلو ريت في stream 4 فاقول له add stream 4 نبي المولر فلو الماستر مولر فلو حق الثلاثة ذلين امونيا والنيتروجين والبتاع اقول له done اقول له place it as a table. Now when we go to the flow sheet, okay, بنشوف ان the 3 things has been given to us here. Okay. مثل ما كاتب هني. So we will see that the nitrogen is 65. Yeah, that's cool. And the hydrogen 195 kilogram mole per hour, and we have بتاع الامونيا 70. And the total is stream number 4 is 330. So if you add this 3 number, you will get 330. So that is the ammonia reaction. Okay, now what's next? Now, it is desired to increase the conversion of the reactant. And to واضح عندك هنا, as you can see, you have hydrogen and nitrogen. They are there. Look to the hydrogen. There is a lot in stream 4. Now, this is gas phase. You can see here that we have 0 molar flow of the liquid. Nothing here. So it's a gas phase. So everything is up. And you can see 195 of hydrogen. So I need to take this guy back. And this is very clear even from the single pass conversion, which is 35%. So to increase the reactant, so for that, we are going to take stream product, sorry, the stream number 4, which is the top هذه. شو بسوي فيه شباب؟ I'm going to pass it to a separator at 0 degrees C. كم درجة حرارته هو الحين؟ 769, which is almost 770, 770 degrees Celsius. He wants us to cool it to produce a stream, a liquid stream, which he called it stream number 6 of mainly ammonia. معناته شوف شنو يبي يسوي؟ يبي يبرد. And he's using a separator to do this. Okay, you want to use a separator to do this. So I have here, if I remember that, and عندكم البتاع temperature, the thermodynamics, okay, just to remind you. Okay, فأنت عندك في thermo, عندك temperature, عندك X and Y, and then you have this nice things like this. Okay, now I am here because everything here is what? It's a vapor phase. هذه 1. معناته I'm somewhere here. I'm somewhere here. صح? I'm somewhere here. Can I do separation if I'm here? Can I do separation if I'm here? Can I do separation if I am at this point? Yes, no. حتى ترى تعبان انا بعدين سكتون هاللون ما اقدر وين اقدر اسوي separation? I have to be where? I have to be inside here, صح? The wet region. For the separation to take place, I have to be here. And how I can take this point and bring it here? What should I do?
Cool it.
Cool it. When I cool it, I'm going to be somewhere here. And then what? Then بيصير عندي separation. فبيصير عندي شوية أشياء تروح في ال vapor, because this is the vapor line. I don't know if you remember this stuff, but you should remember because most of you are doing Thermo 2 this semester. So this is the vapor and this is the liquid. So when I cool, لما أنا بسوي عملية التبريد يصير عندي separation. شوية بيروح على الvapor وشوية بيروح على liquid. This separation only happen when you are here in this wet region. أي حتة تانية لا. إذا أنت liquid تسخن لازم تجي هون. إذا أنت vapor لازم تجي هون تبرد. واضح شباب؟ Then when you are here, separation takes place. حلو. فمعناته أنا الحين عرفت هو ليش يقول لي أبيك تحط لي separator, because I need to separate. Because this is an equilibrium separation. So that's why I need the flash separator. And then he told us I need to cool. And now we know why he asked us to cool. Let's have the separator then. وين السيبريتر؟ View, model palette. طلع search جديد. وينه؟ أكو. حلو. فاحنا شباب الحين عندنا اللي داش عليه stream number 4. وينه؟ 4. وتحت فوق عندي شنو سموه في اللاين؟ 5 وتحت 6. اوكي؟ سمي مثله 5 و6. حلو. بس في شغله شباب، احنا قاعدين نسوي cooling، وبالتالي I have to tell him energy. اوكي؟ تقول له نبيك تحسب لنا الطاقه. فاول ما اقول له طاقه بيقول لك يا بس ما احلك انا. زين شيبي النون بيوتي
temperature
يبي temperature اللي هي كم؟ اللي هي stream number 5 يبيها. طبعا 5 و 6 بيكونوا نفس stream نفس حراره لانه equilibrium. صح ولا انا غلطان؟ علي شكرا الله قولي ترى اذا انا غلطان صوبني. صوبني اذا انا غلطان. ليش شباب نفسها؟ وين رسمتنا الحلوه؟ ليش نفسها؟ لان نفس الهوريزونتال لاين. لا فانت لما تتكلم على الفيبر مني او تتكلم على الليكويد مني اثنيناتهم عندهم نفس درجه الحراره. عدل شكرا الله. اثنيناتهم نفس الحراره. So that's why you put the zero here or here doesn't matter. شباب انتم ملاحظين شلون ثيرمو قاعد ويانا هني ولا مو ملاحظين؟
كل مكان.
So please, all of you have to take attention, okay? So Thermo 2 is here. Thermo 2 is here. يعني قاعد اروح مني وهي في الهايسس, okay? So Thermo is very important. Very important. Again, Thermo 1 and 2, if you have some problem with this, you have to be very careful and fix them. بيساعدونك وايد في فهم كل الكورسات اللي جايه. Reactor design كله. So please give attention حق Thermo 1 and 2. Especially HYSYS شوف كلها Thermo. Anyway. طيب شباب الحين أنا برت. شنو تتوقعون عندي تحت وشنو تتوقعون عندي فوق؟ based on what? based على based على شنو؟ ما أدري based على شنو.
boiling point.
أيوة اللي كتبتهم من ساعة. أنا محيتهم بس ممكن أحب فيكم كتابهم. من كان فوق؟ من كان الهيدروجين كان اللي عنده the lowest boiling point minus 200 شيء صح؟ وبعدين نيتروجين كان اللي بعديه والأمونيا كان أثقل واحد صح؟ So when I do cooling exactly نريمان excellent نريمان نادي. So I expect إن الأمونيا لأنها أثقل واحد بيكون في القاعة. And I assume in the hydrogen because it's the lightest. I expect that I'm going to find it here. Well, let's see. Let's see that our theory is correct. Can't you the composition? Let's see the composition and then we can judge the God at Mohamed Bin Shams adil wala la. Let's see. Where is stream number 5? Okay, so stream number 6. What is the highest thing we have? ammonia, right? Ammonia أكثر شيء 99. Okay, so let's agree with what we see here. Our guess was correct. What about 5 أكثر شيء شنو؟ المفروض أكثر شيء أخف 1. Okay, so the more I should have more of the lightest. So that's what I see here. So I have hydrogen more. And the next best is nitrogen. Okay, the next best is nitrogen. وأقل شيء عندي ذاك الأمونيا لأن كلها راح تحت. Good. So now we are okay. طيب شنو نبي الحين شباب؟ يقول لك to recycle the reactant we have to split stream 5 اللي هو ذي into 2 streams 7 and 8 using a T splitter. Okay, 7, which contain 80% of stream 5, is sent back to the mixer to meet the feed to the reactor. معناته الحين أنا محتاج أحط لي splitter. Okay. وين هذه البلت؟ أربعة هذه البلت. Okay, كاوة. So this is the T. عكس الميكسر T. يتحطها مني. طبعا الميكسر تقول له الانلت مالك stream number 5 والاوتلت I have 2 branch عندي 7. شوف اول ما اكتب 7 he will create it. شوف بس هنا طلعه وعندي 8. زين يقول لك انا ما حليت يقول لي unknown split شو يبي؟ يبي اروح على البارامتر واقول له stream number 7.8 بروحه بيفهم انه 8 20%. فتشوفه على طول حل. شوفه على طول حل. So the splitter now is, as you see, solved. Nice. Now what he told us, قال لنا 70%, 80% of stream 5, which is he called it stream 7 هذه, is sent back to the mixer to meet the feed to the reactor. فإذا أنا على واي ايش بسوي؟ باي حق المكسر. بقول له يا مكسر يلا خذ بعد معاك انلت من اقول له؟ which stream؟ 7. قال لي لازم وايد تراجع. أول ما أقول له راجع شو يصير؟ أوه شلون؟ قال لي not solved. شنو ذي الحين؟ خربطة لا؟ في يا شيخ تربت الحين. So HYSYS cannot solve. So HYSYS cannot solve here. في problem. ليش؟ لأن من ساعة he solved for something else. And now he see new input and there is no match here. There is no match here. Okay. So as you can see here, doing so results in an error, as can be seen below. The reactor ends up not solved. And so most of the process is not solved. This has happened because recycle causes the process to become unsteady, and a trial and error procedure is required to solve this problem. Trial and error? كنا اللي موسى بن شمس يتحكى عنه صح؟ So what can we do? So هذه الخطة ما تصلح. Okay, so we can tell this guy please remove 7. لا I اقتراح فاشل. Okay, so we cannot bring it back. But we need to recycle, so what should we do? We go to the model palette and then we have a block called recycle. Welcome to our new friend, recycle. Recycle block. Now let us double click on this. Woo, what is this? What is this, Shabab? What is this hashed line here, that this 2 line? Does it remind you of something? I've seen it today somewhere, صح? Yeah, it looks like this guy. صح ولا لا شباب? Can you see, guy?
Yeah.
Looks like this one. It's a tiered. It's a tiered thing here. So, it's mean that he's going to use the tiering techniques. He's going to use the tiering techniques. So the inlet of this is 7. شوف الحين أنا دخلت عليه. كأنه المقياس. And I'm going to tell him that the outlet is 7R. Recycle, 7R. Now, when you press enter, طبعا لاحظ I didn't attach. So this is basically nothing. This is like a pipe. So the composition here is exactly as the composition here. Nothing changed. Still, this is not recycled yet. This is not recycled yet. So, so if you look at the composition of 7, okay, it's exactly the same as, look here. This is the same exactly as this here. Okay, ولا شيء متغير يعني I didn't do thing yet. However, when I call now, when I go حق المixer now, can bring for me 7R, all that thing that I have explained will happen. So an iteration will take place now. Before I even do this, let me put for you here the compositions. Okay, well, it's already here. لاحظوا شباب 7, look at 7 and 7R. Can you see them? Numerically, they are exactly the same. 7 and 7R. Nothing happened yet. But now, I'm going now to call 7R. Okay, now I don't know if you notice here, something happens. صار في iteration شباب. صار في iteration. And look now at 7 and 7R. Can you see, guys? 0.2400, 0.2399, 0.7257, 0.7259. Iteration happened. Iteration happened. And how he did this trial and error? Well, let's go to this numerical thing. Ooh, this is Bin Shams' friend is here. Finally, we see it. The wax time. Okay, the wax time. So they use the wax time methods in order to do this iteration. Okay شباب، فهو في numerical شوف حتى كاتب لك numerical. So there are numerical iterative things happen in the background, and it show you سوت لك الiteration required for this recycle. That's it. So this is how we do recycle, and it's been explained to you with lots of details. Okay, أنا كان ممكن أصلاً أبطل لكم السؤال وأجيب لكم الريسايكل وأشبص لكم ذي وأخلص, but you will never know what happens because you have seen يعني الموضوع جدا بسيط. تحط الريسايكل، تحط 7R، بعدين تناديه بروح يصير calculation. So that's why the understanding the tiering techniques شلون تشتغل مثل ما شرحت لكم manually is important. Okay, it's important. Yes, it's very easy. It's very easy. Okay, but it's very easy to use it, but you really have to understand how it works. Okay, عشان كذي أنا قبل كنت أخليهم يسوونه manual على الإكسل، بس يعني تاخذ وقت شوية. But maybe doing it once عشان تثبت في بالك tiering techniques, because this is exactly what HYSYS use. شلون عرفت بن شمس؟ أقول لك شوف هذه الرسمة، تقول لك تختصر القصة يعني. Okay. Yeah, it doesn't change much. Yeah. Okay, it doesn't change much, but yeah, because this example is easy, لكن في المسائل المعقدة غير. زين هو it doesn't change much, but if you don't put the recycle مثل ما انت شفت مساعة علي شكرا الله ما ينحل. So you have a problem. طيب في شغلة ثانية شباب هني يطلب من عندنا he wants us to calculate the overall conversion. يبينا نحسب شباب ال overall conversion. شلون احسب ال overall conversion شباب؟ How can I calculate the overall conversion? Now inside here we have a single pass conversion of 35%. لكن الحين انا سويت recycle. فاذا انا سويت recycle معناته ال overall conversion بيتغير صح؟ So how we calculate the overall conversion? Anyone can tell me? Basically بيكون ال overall conversion ال overall conversion is what شباب؟ طبعا نتكلم عن ال conversion مال النيتروجين صح؟ So N nitrogen minus N out nitrogen على N nitrogen. كم النيتروجين اللي دخل؟ Well, why we have to do it? Well, خلينا نخلي المطلع السبريد شيت، خلينا نسوي سبريد شيت ونسويها صح؟ زين من وين يطلع نيتروجين؟ Where we have nitrogen, we have in stream 8 صح؟ We have nitrogen in stream 8, yeah? Where else? We have here in the separator 6 and then the nitrogen as well, صح? Do we? Yeah, we have nitrogen as well. And when بعد بيطلع هني ما في nothing. So 6 and 8. So basically N is stream nitrogen. Okay, and then هني 6 to 8. So we can use a spreadsheet to calculate for us the overall conversion. خلينا ناخذ spreadsheet. Okay, so spreadsheet نقول له يلا في السبريدشيت نقول له هني ايش عندنا؟ نقول له ال N2 النيتروجين فيد صح؟ وهني شنو؟ النيتروجين ستريم 6 عندنا النيتروجين ستريم واحد أي واحد 8 صح؟ nitrogen for stream 8. So this is the nitrogen for stream 8 or this is the nitrogen for stream 6 وهاي الفيد. وهذه شنو؟ هذه بنسميه overall comp بالpercentage. الحين when you right click here we have to import الفيد اللي هو stream اسمه nitrogen صح؟ النيتروجين وش ابي منه؟ ابي منه الفلو المورال فلو صح؟ اللي هو المفروض 100 يس. النيتروجين 6 right؟ من stream number 6 بقول له add variable stream number 6 بقول له ابي molar flow بعد master molar flow وابي من ابي النيتروجين as well فبيجي لي اللي هو هاي الرقم and طبعا لاحظ هذه اسود هذه ازرق because this was an input parameter and this was like calculated parameter باي اني بعد بقول له add stream number 8 صح؟ بعد بقول له master molar flow nitrogen بقول له down. Now شلون احسب الconversion the overall conversion? How can I calculate the overall conversion? What do you mean when I use master when I don't use it? When I don't use it شنو يعني? Okay, let me complete this and then I'll answer your question. طيب شلون نحسب الفيد? So we we have a bracket divided by B1. And what do we have inside the bracket? We have the B1 minus, we have a bracket, and inside this bracket we have B2 plus B3, B2 plus B3. And probably I need to multiply all this by 100%. And that gives me this number, 72.75. So this is the overall conversion. This is the overall conversion. And let us show it here. فإذا أنا أروح وين؟ فطلعها هني مثل ما سويت من ساعة. فراح كاستمايز data table, add، بقول له admin، بدي spreadsheet، عطني B4 اللي حسبت عندنا صح؟ yes. بقول له done، place it on a flow sheet as a table. Go back to the flow sheet. So now you will see that this is شباب overall conversion. This is the overall conversion. طيب خلنا أسألكم سؤال شباب. شلون ممكن أكبره؟ How can I make the 72.75, which is the overall conversion, how can I make it bigger? How can I make it bigger? Any idea? شلون ممكن أكبر overall conversion شباب؟ شلون أنا زيدت الكونفرجن أصلاً؟ شنو سوينا عشان نزيد الكونفرجن؟ زيدت حطيت شنو؟ الموضوع كله عن من؟ عن الريسايكل ستريم صح؟ Yeah, it's about recycle stream. No, actually we don't reduce it, we make it more. We make the split أكثر من 80%. Okay? So now if I go to the splitter and instead of 80, حطوا بالكم على الconversion صح؟ حطوا بالكم على overall conversion. If I go to the parameter وأقول له بدل 0.8 بقول له 0.85. Look to the overall conversion. زاد. معناته if I increase the recycle, the overall conversion increase. خلينا نقول له 90%. Look, 84% conversion. What if I recycle everything? Okay. I get 99.47. I'm getting 9. Look here, I have nothing goes in this stream. Well, this problem, I try a kind of hypothetical problem to explain for you the idea of the recycle. لكن انت عارف ان عندك inert. So you cannot go with 100% recycle. يعني انت الاير النيتروجين دائما يكون معه argon. تعرفون عنصر الارجون موجود في الاير، CO2 بعد موجود في الاير. So these are inerts. So they all exist. So you will never have 100% like what I did now. But let me ask you a question. Why am I using 100% and I'm getting 99.47? Why I'm not getting 100? Why I'm not getting 100? I'm recycling everything. Why I'm not getting 100? The separation is not 100%. وين شكرا الله separation not 100%? في وين? Stream 6. Yes, Nariman. Exactly. Look here, شباب. Look here. Stream number 6 في نيتروجين شوية. في شوية نيتروجين هنا. بالتالي ما عندي. I lost some of the nitrogen. And that's why طبعا مثل ما قلت لكم in practice we will never have 100%. We have مثلا يعني أعتقد 0.8 هو representative number. Yeah, حتى أقل من 0.8. And that's basically complete أعتقد the problem ماشي that. Yeah, so this 72.75. Okay. the value that we have just calculated.
دكتور
Yes.
لما سويت السبريد شيت في أول واحدة حطيت مولر كومبوزيشن، الثانية حطيت ماستر مولر. متى أحط ماستر مولر متى بس أحط مولر؟
لأن الستريم N2 ما في إلا okay, let me go back here. Edit import variable. الستريم N2 اوكي نفس بعض هم بالنسبه حق الستريم N2. يعني تروحين على الماستر مولر فلو ريت، هني الستريم اتس بيور N2 اوكي، لان بيور N2 انا رحت على المولر فلو. لكن حتى لو اخذته من هني يعني نستير، خلينا ارويك اياه من هني نيتروجين اوكي، لو اخذته انا الماستر كومبوننت فلو ريت سيلكت بيعطيني نفس الشيء ما بيتغير. بس لو كان عندك الستريم يحتوي على اكثر من كومبوننت you have to go to the master، او ما تبي تعاونين راسك كله روحي على الماستر اوكي. يعني هو هني اوريدي في الماستر ما عندي انا، يعني شوفي هني اذا رحت على ال N2 ورحت على الماستر مولر فلو ريت هنا المفروض ما يعطيني شيء امونيا زيرو سي، ما في شيء لانه بيور N2 اوكي.
Okay, thank you, doctor.
Thank you. Any other question شباب regarding this؟ خلينا نعد الحين خربت لنا ال M2، خلينا نحطها مثل ما قالت master عشان ما ندون لها حاجة. So it's a 100 and everything fine. Any other question شباب؟ أحب فهم شيء شباب؟ في أحب فهم شيء؟ Anyone understand anything from all this stuff? Wow, if it's everything is clear with this complicated stuff, then you are really good guys. تمام. So إن شاء الله نشوف more problem next time. طبعا شباب لاحظوا صرتوا تعرفون شيء وايد الحين في الهايسس، يعني كسيبريت units صرتوا تعرفون الست، صرتوا تعرفون الادجست، صرتوا تعرفون الريسايكل، صرتوا تعرفون الميكسر، السبليتر، السبريدشيت، conversion reactors, separators, compressors, coolers, heaters. Okay. فصار عندكم شوية يعني that was the purpose of introducing HYSYS in this course 315. شوي مثل ما يقولون نعطيكم مقدمة and we break the ice with HYSYS. طبعا إن شاء الله في الكورسات اللي جاية تبدون تأخذون أشياء أكثر and then you're going to build up on what I have introduced to you now. بس طبعا دائما المقدمات مهمة، يعني إذا الأساس شوية لك عليه فبعدين بتقدرون كلها تقولون كلها من بن شامس. So please don't say that. if you have any question, please ask me, whether now or even after through the chat. طيب, if you have guys any more questions, then I'm going to stop here and see you inshallah next time.
دكتور لوين دخل ويانا تف 2؟
ليه ما وقف إيه يعني بيكون HYSYS أكيد فيه يعني we have been covered many things in HYSYS يعني بيكون simulation وأقوم يعني مثلا واحدة من الأسئلة اللي ممكن أسألها لكم أعطيكم شيت مثل ذي وأسألكم مثلا أعطوني overall conversion، أسألكم على overall conversion، فأنت عشان تعطيني overall conversion لازم تحلين السؤال كله something like this، أو إن أطلب طلب ثاني يكون خبيث أكثر من الطلب لي يعني حاجات كذا يعني. Okay guys, thank you very much. Have a good night. تصبحون على خير.